Okay, welcome back. This is video number 2, exploring national land cover data over the Spanish Fork watershed in Utah. And this is for the Chapter 3 of the Advanced GIS class and practical application number 6 in that book. So I was successful in clipping the land cover data from 2004 and 2024. There's 2024. Here's 2004 on top of it. And that was actually somewhat tricky. And I realized a couple of things that I'd share with you about the two different sources, which I showed in video 1 for acquiring the data. So I had mentioned both Earth Explorer and the MRLC viewer. And what I found with the Earth Explorer download is that they are tiled. And so that tiling does create a risk. When you download the tile, you may found, like I did, that the tile actually cut off part of the watershed. And well, the good thing about the MRLC viewer is that whatever polygon that you down or choose as your area of interest will be what the download is produced. So if you use your email, they'll send you a download link. It'll download automatically when you click the link. And I'll show you what I got when doing that was a polygon like this, which is what we kind of expected. So yeah, the MRLC viewer is the most customizable in terms of the shape area. Alternatively, you could use the Earth Explorer and download a bigger area, or like multiple tiles. You'd have to stitch those tiles together in the case where there's partially through the watershed here, and then afterwards cookie cutter out the watershed. Okay, so I've gone ahead and clipped those rasters to the watershed area using that watershed polygon and choosing to use the kind of cookie cutter clipping as I described in video 1. So the next thing we want to do, right, is to be in this video, we want to basically calculate the area and percentages of land in each type of land cover class by year. So we want to see what was the state of land cover within the watershed in 2004 and 24. And we can visually see it right now, but those visualizations are all very qualitative. We can qualitatively say there's differences between the 2 years. We lost a lot of forest for some kind of grasslands throughout that 20 years, clearly. But we can quantify that. And so how do we do that? You could use something potentially like zonal statistics or raster calculator. But I think the best way is to turn these raster classifications into polygons. And so that's what I've done. Tested out the first one, which is I'll show you right here. So this is a raster of basically that land cover classification. It doesn't quite, it might look quite much like the pixels and the same because as I turned it into a feature class, I told it to not simplify the polygons. I wanted to keep the kind of shape of the pixels and not make an extra interpolation. So how do we do that? So basically we can use conversion tools, raster to polygon. And what you do then is you can put in one of your clipped rasters, and you want to output the value of the raster, I believe. So if we right click and look at the attribute table, we see that the value is those are going to be your different polygons, are the land cover class values. And so here's 2024. So the output would then be, so we might call it Spanish Fork Watershed 2024 land cover polygons. I unchecked the simplified polygons and I created multi-part features. And what that means is that for each value field, there'll be just one feature. So each land cover class will create one feature and then they'll sum the area up for them. And I'm not creating any maximum vertices for feature. I'm just going to let it run. So that's 2024. The other thing I'm going to do here is I'm going to output it in a local coordinate system of the watershed, which is in UTM. Okay. Go ahead and run that. And so when you run that, you get a set of polygons. They're not classified as anything. And so that is a tricky thing. So this little kind of over-described version below what I just produced is another one that I went ahead and already kind of color classified it. But I'll show you how you would do that. So you go into symbology and you have to go to unique values by grid code. And then it'll automatically choose some colors, and that's fine, but that's not great. It would be nice to use the actual colors that are that the National Land Cover Dataset utilizes. And those are shown in table 3.1 of the book, including the RGB values. And so you can go through and let's say like 11, grid code 11 is open water, and RGB values are 70 for R, red, green is 107, and blue is 159. So if I go into the color, I can go to color properties, RGB, and I can say 70, 107, and 159, and then okay, now I have my blue water class, open water, and I would have to go through and do that for each of these to produce exactly what I want. Or once you've done it for, well, I guess you would hope, right, that you copy in like kind of the layer classification from these other things. I couldn't figure out how to get that to happen for the polygons. It was very easy for the classified raster, but I had to go through for this one and enter all those color codes. But once you've done it once, you should be able to import that symbology to this one. So let's see if that's true. So if I import symbology from this other one and say run, hopefully that works. And it seems to have done so. So you can see now the colors, and they look right like they did down below. Okay, so there's my 2024. Let's do that again for go back to geoprocessing, raster the polygon. This time we'll do 2004. Again, value field, and we're gonna this time call it Spanish Fork Watershed 2004, and then land cover poly Not going to simplify, going to create multi-part features, and we're going to get that into UTM coordinates and run that. And then we can copy that symbology again. Now we might run into some small issues if, like, from one year to the other, they don't have all the classes. You might have to manually enter one. Okay, so there's 2004 and 2024. Okay, let's see if that's true. So there's 2004 has a lot of forest, and we don't have a lot of forest in 2024. Yeah, so that worked. You'll notice that on these polygons, I don't have any outlines. That way they kind of aren't, if I did, then I'd have a lot of gray that would kind of mute out the different color classes. If we look in the attribute table for these, so these other ones. So what it shows us is that for each grid code, um, it gives the length of those polygons. And remember, they're multi-part features, and then also the total areas in the units of the feature. And the units of the feature in meters. So these are in square meters. So 180,000 square meters of open water in the 2004 polygon. Let's compare that to the attribute table 2024. 180 versus 142. So there's less water in 2024 than there was in 2004. And so the big things that we thought changed were forest and whatnot. But we could, at this point, basically, we got some information about area. And so we could get like percentages of the watershed potentially and things like that. And so what we want to do probably is to modify these attribute tables similarly to each other and get some more qualitative things in here as well as quantitative. So let's just give some examples. So we could add in a field that's called classification or class. We could call it text and save. And then we go back here for 2024. We should have, now we have got that class, and this is open water. And then the next one is called, well, this is not the next one. This is 21. That's developed open space. The next one is developed low intensity. I'll abbreviate that. Developed medium intensity. Developed high intensity. So this is a bit tedious. And then barren land, and 41 is deciduous forest. And then we have evergreen forest, mixed forest, shrub, scrub, 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 scrub. And then grass land / herbaceous and pasture hay, cultivated crops, woody wetlands, and emergent wetlands. Emergent herbaceous wetlands. Okay, cool. So that is a little bit more clear than 11, right? And so then I'm going to add another field in here. Oh, I need to go to edit. I've been editing, so I need to save. And then I can add another field. Now, this is going to be a percent. And as such, I'm going to have it be a float. Have some decimals. And the total area is this of the watershed. So I'm going to copy that. And um, and so now I'm going to go in here and I'm going to say calculate field for percent. And the percent is going to equal the shape area divided by that total area of the watershed, which I copied. Okay. And then we put parentheses around that. And I'm going to multiply it by 100. Could do this in a code block too, but not necessary, I believe. Now, let's see, did that actually work? It doesn't quite. Not sure. So if we sum all of those up, well, I guess I'll do look at it. So 55.6, 2.2, that's 57.8, 59. Yeah, I think they will add up to near 100, right? Because between this and this is getting close to 40. Yeah, so most of the land cover in 2024 was either deciduous forest, evergreen forest, but then primarily shrub and scrub. Everything else tends to be less than 1% of the land area of the watershed. Okay, so good. So we can kind of do the same, right? For the other one. Um, and so again, we could add a field and we could call it percent. You could add watershed area or something if you preferred to make it a little bit more clear. Save. And then we go back to 2004. And I haven't added the grid code classification, but get the idea just to save a little time. So now we'd say it's the shape area, again, divide by paste. Okay. So so back then 52, I believe, which is a shrub and scrub, was only 34%. So that increased to 55%. So 20% of the area went from other things, types of forest, down to shrub and scrub. And then a lot here, almost 2% was this code 71, which is grassland. Oh, that's pretty similar, actually. Grassland's gone down as well in 2024 to shrub and scrub. Um, Yeah, so that gives us basically in these attribute fields, we can have the percent of the different land area in there. And then we could compare them year by year. You could do that graphically. Um, could visualize these statistics in some way. You could take, that's probably not the best way, right? You could make a pie chart. You could do what you would like with this data. Um, let's see what sort of create a chart. So we were going to do a pie chart. And so um, so we have classes. That's not right. There we go. So shrub and scrub, we'd need to edit this a bit, but you know, that gives us a bit of maybe the pie chart's not the right tool, right? Given that so many of them are less than 1%, it's hard to read. Might be better just to do it in a table to compare those different years. But pretty easy to summarize then that. And you can do it by percent and total area. You could change these areas from, you know, meters squared, which and these big decimals. You could maybe make another field that said area miles or something. And you could just make it a short integer, and so it'd be rounded off just to make it look easy. Or that was kind of silly. Probably shouldn't have done that. Leave it as float, and then you'll have at least a decimal on there. But just for reference, so now I could go and calculate geometry, area in miles, area, aerial unit in square miles. And so then you could say, think 353 square miles of shrub and scrub, right? Instead of percent, you know, how many square miles were lost or gained. Um, yeah, so this this should be pretty helpful. So basically in this video, we've looked at the national land cover data. We've taken it from a raster to a feature class. We didn't simplify those polygons to try to preserve their areas as best we could, not introduce other issues. And then we're calculating areas of the watershed, which are covered by these different land cover classes, and also the percentage that represents. Um, and so then from that, we can make tables and charts, which we could add on as graphics to our map outputs, making some quantitative kind of add-ons to this visual representation of the land cover across the watershed. Okay, so that's video 2. In video 3, we're going to identify areas of land cover change, and so we're going to figure out where those areas have changed. And we'll put it all together with some presentation of this information in video 4. So we've done step 1, we've got the data, we've clipped it to the watershed. Step 2, we've turned it into a feature class, which we were able to get good information about the aerial statistics. And now we're going to see where the change was. Okay, so we'll stop this video and we'll move on to video 3.